And question 2 actually has 8 parts, believe it or not. And again, this is how important Lewis structures are. And what you'll see, as always, is that when you see more of something on the homework, you will see more of it on your exam. And so your exam is not for a couple weeks yet. It's not until the first couple days of December, but we're always learning these things to get ready for the exam. And what I've done is I looked at the 8 problems and I thought problems 2 and 3 would be good problems to do for you to show you how this works. The problem statement number 1 says, although I don't know why it says number 1 for each of them, but for the following species, draw the best Lewis structure, including doing a FC or formal charge analysis for SO3 2-, which is the sulfite ion. Please submit your work as a PDF. We'll do both of these, and we'll start with sulfite. And we went over the rules the first time, so now we'll go a little more quickly. If you look on your periodic table, sulfur has 6 valence electrons per atom. Then each oxygen also has 6, and there are 3 of them. And this is our first ion. So, and what we have to know is that when it's 2- or -2 for the charge, that means add electrons, because electrons are negative. And that's a little tricky, but we'll get used to it. So add 2 electrons, and that gives us 6 times 3 is 18, 20, 22, 24, plus 2 is 26 electrons. And because these 2 electrons are not truly valence electrons, they're electrons that this species has picked up from somewhere else, I tend to just write electrons here. And another point is there are multiple ways to do Lewis structures, and my method for doing Lewis structures always assumes that the 26 electrons belong to the molecule or ion, not to any specific atom. There's ways to do it where they belong to atoms, and I'm fully aware of that, and you can do them that way, and I'm happy to troubleshoot. But this is the way that I think is easiest, so that's the way I'll do them. Now, we have our electrons. Take the atoms and put the least electronegative atom in the center. Sulfur is going to be the least electronegative. It also turns out that the first one tends to be the central atom as well. So sulfur is least electronegative. And if you'll remember your trend in electronegativity, it goes like this. Oop, let me draw my little picture of the periodic table. There's fluorine. As you go to the left and as you go down, electronegativity decreases. And sulfur is under oxygen, so sulfur going down must have a lower electronegativity. That just means put sulfur in the middle, connected to the oxygens with single bonds. Each of those single bonds represents 2 valence electrons, which means that I have 2, 4, 6 total. And the way that I do it is I tend to count them out as I go. And let's see, I think in my guidelines it now says you're supposed to sprinkle the rest of the valence electrons around the outside atoms first, completing octets. So I have 2, 4, 6, 8, 10, 12. So, and this oxygen now has 8. So it is good, it is happy. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, I've put in 24, I still have 26. And this is a real rule for Lewis structures. This is a real way to keep all of your points on exams, is always put exactly the number of electrons you have. I've only got 24 so far, and all of my atoms have octets. So the last two have to go in the center. And you can see right now that all of my atoms have octets. And this is a good place to be, though we are not finished. Are there any questions about what I have down here so far? Okay. Then the next thing we're going to do is what's called a formal charge analysis. And if you're looking on the internet or Google, some places will say that this is your final answer, but that is not our final answer. Our final answer will always have a formal charge analysis. And a formal charge analysis, when you compute formal charge, and that's what FC, capital FC, stands for, it does not stand for football club, like in the UK, or many other parts of the world. The way that you compute formal charge is formal charge equals the number of, and we'll just do this, let's do oxygen first. For it's the number of valence electrons from the periodic table. Number valence electrons from periodic table. And I'll answer that question in just a minute. Number of valence electrons from the periodic table, which for oxygen, and this is formal charge on oxygen, is 6. And we already know those numbers from up here. Minus the number of bonds plus the number of unshared electrons. Oop. Number of unshared electrons, that's what that says. And for this oxygen right here, there's one bond, and there are 1, 2, 3, 4, 5, 6 unshared electrons. So 6 minus 7 is minus 1. And that means that this oxygen has a formal charge of minus 1, and that means put a minus with a circle around it. The minus is because it's minus 1. The circle is how we indicate formal charges. Now it says we have 26 electrons, but only 20 is shared. Why? So I would say in this Lewis structure, if we count up the valence electrons, there are 2, 4, 6 electrons so far that are shared, meaning this pair of electrons right here that I'm pointing to is shared between this oxygen and this sulfur. Same thing here and same thing here. So there are actually 6 electrons shared between the sulfur and its oxygens. And then it's 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 total electrons. And I don't know if I've addressed your question or not, but please ask again if I have not. But this is, so let's continue, though again, please ask again if I didn't answer your question. You can see this oxygen down here is exactly the same as the one here as far as formal charge goes, because it has one bond, and 1, 2, 3, 4, 5, 6 unshared electrons. So its formal charge will be minus 1 as well. And we have another minus 1 formal charge over here. Now, let's do sulfur. Got it. Formal charge on sulfur. Sulfur, the number of valence electrons from the periodic table is 6. It's in the same row as oxygen. And this one has 1, 2, 3 bonds plus 1, 2 unshared electrons. So it's going to be +1. And that means we put a little plus there. And hopefully this makes, not that this makes sense, but the formal charges, when we add them up, so -1, -2, -3, +1 is -2. The formal charges must add up to the total charge on the ion. So I'll write that down here. Formal charges must add up to charge on ion. Now, when it says doing a formal charge analysis, and it says draw the best Lewis structure, the best Lewis structure has the minimum amount of formal charge. And there's one thing we can do to minimize the formal charge for this one. And does anybody remember what that is from the lecture outlines? And it's specifically for sulfur and some elements.
Create a double bond.
We are going to create a double bond, and that is going to give sulfur what's called an expanded octet. So we will minimize, sorry about that, minimize the amount of formal charge. And the way that we can do that is we are going to form a double bond. And when we form the double bond, it doesn't matter which oxygen we use. You can choose whatever one you want. But you're going to take 2 of the electrons and move them over to form the double bond. And our final answer will have sulfur with this layout. And then because it's a Lewis structure, you must draw all the pairs of electrons. And typically I try and do it so that these electrons move over so they're not there. But really, as long as you have the correct number of electrons on each atom, I'm happy no matter what. Let's see, then I got my pairs down here, which nothing happened to. I've got my 3 pairs of electrons over here, which nothing happened to. And I've got my pair of electrons on my sulfur. You can see that nothing's changed on these oxygens. They still have negative formal charges.
But why the 2 Lewis structures above the sulfur? I thought that doesn't it have 10 now? Because
yes, and that's okay.
To be 8.
Yes. So then that's why it's important. So some classes and some online videos stop here when all atoms have octets. But there is a better answer, and the better answer minimizes the amount of formal charge. And so what we just did was, when we do a formal charge analysis now, we will see that the formal charge on this oxygen is now 0, and the formal charge on this sulfur is now 0. So we've taken away these 2 formal charges. And
you still have -2, okay.
Yes, and we still have the -2, but we have to have the -2 or the 2 separate negative formal charges because it has to equal the -2 up here. So we can't do any more. Oh, and so now, yes, sulfur can have an expanded octet, and sulfur does have an expanded octet. Which is totally legit. And, you know, I lost my periodic table here. I must have taken it upstairs to work on some problems. But in the video, and I'll try and get it coming up, but in the video, the atoms that can have expanded octets are going to be, so on the periodic table, there's aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And these are in the 3p region of the periodic table. That's an S, believe it or not. And these atoms and anything below them can have expanded octets. And the reason they can have expanded octets is since they have electrons in their 3p sublevel, they can store any extra electrons in their expanded octets in the 3d sublevel. So 3p can have expanded octets by putting electrons into 3d, putting extra electrons. Sublevel. Because one of the things we learned about the n equals 3 sublevel is that if you have the S, 3s, and the 3p, and the 3d, they're all in the same volume of space. Anyway, we don't talk too much about how they get those electrons get into the 3d sublevel, but they can. And the elements above these on the periodic table, the fluorine, the oxygen, the nitrogen, the carbon, they're in the 2p region of the periodic table, and there is no expanded octets. Because there is no 2d sublevel to put extra electrons in. All right. And so by far the most common elements to see expanded octets are phosphorus, sulfur, and chlorine, though other ones can be seen. And that means that this is our final answer. This is the best Lewis structure. And our process, and this is, by the way, probably one of the most complicated Lewis structures we will do as far as process. To remind you what our process was, we found our valence electrons, we added 2 for charge, we put them in until we had octets, and then we did what's called a formal charge analysis. And it led us to form a double bond and create an expanded octet for sulfur. An expanded octet for sulfur. And we talked about which elements can have expanded octets and which elements cannot have expanded octets. So yes, I know it's a lot to chew off at 8:30 or 9 in the morning, especially when I haven't had as much coffee as I would like. But Michael or anybody else, anything you want me to review in this problem? I know I've only done this first one, the SO32-, and I still have the IF3 to do. But any questions on this one?
When you do the I get why you do the first step first when you do the Lewis dots around all the atoms. But it just throws me off because I originally wrote the double bond first, and that doesn't change the formal charge analysis. I'm trying to do it in my head. I know okay, we got 6. You got how many bonds there are. That changes the bonds though, doesn't it? Because you've got now, I don't know. See, now you have 3. First we had 3 bonds, but now we have 4 bonds for sulfur, right?
Yeah, so let's do a formal charge analysis on this sulfur. So sulfur, if we come back to this one, it still has 6 valence electrons from the periodic table. Of course, that never changes.
Right.
But now it has 1, 2, 3, 4 bonds, and still the 2 unshared electrons, which means it has a formal charge of 0 now.
So which is the right answer?
This
Yeah,
one is the right answer.
Because it has a minimum amount of formal charge.
Yes. And this is part of our process.
Is there a way to check, like to proof your work, to like see if you have the minimum?
Yeah, so yes. So is there a way to see if you have the minimum? So the minimum will be the 2 minus charge. And so maybe let me broaden the question. How can we check to see if we have the right answer? Okay. So that is one of the checks, is that you have the minimum amount of formal charge. The next check is that minimum formal charge is on the most electronegative atoms. And so you would never, or almost never, in your final answer have a 2 minus or a 2 plus anywhere. It's usually just single minuses or single pluses. And then what I always like to do is, at the end, make sure that I've got the correct number of electrons, because when you do these, especially at first, the electron pairs fly around. And especially if you're erasing them and putting them back in, you can end up with different numbers. And let's see, 2, 4, 6, 8. And actually, the way I count them up usually is I count 8, because I know the oxygen has 8, plus 8, plus 8 is 24. And then I add the last 2 here for the 25 and 26. And so yes, this does have the right number. And then you can recheck your formal charges. There's actually a lot of checks to do, like including checking formal charges, but I'm trying to think what else. Yeah, I mean, the most common mistakes I see is that you don't do the formal charge step, or when you do the formal charge step, and I do this sometimes too, I'll forget 2 electrons because I'm so involved with making this double bond. So it's useful to go back and just look and say, okay, did I transfer all my electrons correctly as well? So I think those are most of the checks I know of. And Michael, if you said you put the double bond here to begin with, so
yeah, but I didn't put the 2 Lewis dots above the sulfur. I think I only had 24.
Yes. Yeah, no. So always go back and check. And think of it this way. If you know the final answer, you can write it down. But this process will end up helping you if you ever get stuck. And then the last thing I'll say is, if I get to a place in my Lewis structure where I feel confused and I don't know how to proceed, I just erase everything or get a new sheet of paper and try it again, because you can get into a, you can quickly get lost on these. I know I have. And I'm like, all right, start over, go back to my set of rules. I know I have 26 electrons. Let's see how I can put them in. But yeah, as long as you get your final answer, I'm happy. Okay. All right.